Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So 11 o'clock, still morning. So good morning then. Okay, so first kali nak tanya sound dulu lah kot. Screen okay ke? Sound okay ke? Ada apa-apa masalah tak? Nampak muka ke? Ke tak nak tengok muka? Kita boleh tutup kamera. Okay, semua benda okay? Boleh dengar dengan clear ke? Hari ni pasang kipas yang kat bawah lah. Tak pasang kipas atas. Kotlah bising sikit ke apa ke? Okay je? Okay. Bising nanti bagi tahu lah. Okay, so now function and graph. Okay, Alhamdulillah semua okay. Alright. Okay, so now let us start with the second lecture out of 4 for function and graph. So basically for next week, we are going to finish function and graph. And then we will proceed with chapter 6, polynomial. Okay, function and graph. Let us proceed from the last time. How? Okay, how? Baguslah. Okay, so table of content. Okay, so now we are at functions. So I'm going to do example 5 on functions. And then we are going to do 5.2 for the composite function. And then this is the subtopic for next week. Okay, so continue from last lecture. So I told you to do example 5. Okay, so sketch the graph of the following function and state the domain and range. Okay, so this is a linear function. So for linear function, you can do it two ways. The basic thing is that we need to find out 2 points, and then once we have those 2 points, we can actually use a ruler and then just draw a straight line. Okay, so penting sekali kena ada 2 point. So how do you get 2 point? It's up to you. You can choose any 2 point. Choose any 2 points. Or what you can do is that you can calculate what is the y-intercept as well as the x-intercept. Okay, so that is basically up to you. Okay, so normally for me, if there is no restriction about the domain, normally for me, I will calculate what is the x-intercept and the y-intercept. Okay, so x-intercept, make the y equal to 0. So 2 minus 2x is equal to 0. 2x is equal to 2. X will be equal to 1. Okay, so this is the x-intercept. For the y-intercept, you're going to substitute x equal to 0. So we get y equal to 2 minus 2 multiplied with 0. So that means y is equal to 2. Okay, so draw your x's. So the x and the y. Okay, so when x is equal to 1, y is equal to 0. So atas pasti x. So kita akan letak titik 1. And then on the line for fx, we're going to write down y equal to 2. So nanti kita letaklah 1 point dekat x, 1 point dekat y. And then kita gariskan dia. Okay, so this is 1, this is 2, and then of course, you're going to take your ruler and then simply draw a line. Tak kena lah pula 1 tu. Tak apalah. Anggap je lah sini 1 Okay, so those are our graph. Okay, so how do we determine the domain as well as the range? Okay, so if there is no restriction for the domain will start from negative infinity up until infinity. Apa maksud restriction untuk domain? Okay, so kalau ada restriction untuk domain, dia kena tulis x daripada 2 sampai 5 contoh. So this is the restriction for the domain. So if I do a restriction for the domain, I need to make sure I check the range as well. So I'm going to substitute what happened when x equal to 2 and then what happened when x equal to 5, and then I draw that line. Okay, so now I don't have any restriction, so that means the domain will start from negative infinity until infinity. The same goes for the range as well. So negative infinity until infinity as well. Okay, so domain negative infinity to infinity, range also the same, negative infinity to infinity. If you don't want to write down negative infinity to infinity, you can also use the real number. So real number tu maksudnya semua nombor lah. Okay, so that is the first one. Okay, A, B. Right, so we have fx equal to x minus 2 square minus 9. Okay, so this is already in completing the square form. So we are going to compare them with x minus h square plus with k. So A. x minus h square plus k. So h and k, those are our vertex. So hk is the vertex. Okay, what happened if you don't have them in completing the square form? Then that means you have to use the formula where we have h equal to negative b over 2a. So those are to calculate or to find out the h. So yang ini dah dalam bentuk completing the square, so we can directly compare with the formula and then we can easily see what is the h and the k. So vertex, it can either be a minimum or it can be a maximum. That totally depends on the value of a. So when you factorize them, you should be able to see that the number in front here is positive 1. So we're going to have a smile graph. So this point will be the minimum point. Okay, so the minimum point, if you compare them, you should be able to see that h is equal to 2 and k is equal to negative 9. So the vertex is at 2, negative 9. Okay, so this is my minimum point. And then of course, you can let them equal to 0 and then find out what is the x-intercept. So kita nak tahu dia cross dekat part CX ni dekat nilai dia berapa, we're gonna let them to be equal to 0. So x minus 2 square minus 9 equal to 0. So x minus 2 square is equal to 9. So x minus 2 is plus or minus square root of 9, which is 3. Okay, so you can have x equal to 3 plus with 2, or another one is x equal to 3 minus 2. Negative 3 plus 2, sorry. So 3 plus 2 or negative 3 plus 2. So those are the x-intercept. Okay, oops. Okay, so that means this point over here, this is 5 and this is negative 1. Okay, so what is the domain? The domain for a quadratic function is always negative infinity to infinity. We don't have any restriction for the domain. So it will go from negative infinity to infinity. Lagi sekali, kalau ada restriction, they are supposed to let you know that x will be greater than or equal to something. So this is the restriction for the domain. They didn't tell us anything, so that means the domain will go from negative infinity to infinity. Okay, so range. Range totally depends on the function or the graph. If you have a smile graph, then you will start from the minimum point. Let's say I call them as a k. So k go until infinity. So this is when you have a smile graph. What happens if you have a sad graph? For a sad graph, this point is actually a maximum point. So we will have negative infinity up until k. So those are how we know whether do we have, what kind of range do we have or what's the formula for the range. Okay, so this is a smile graph. So I will start from k up until infinity. So my k is negative 9. So this is negative 9 up until infinity. So that is the range. We don't have anything that is lower than negative 9 because that is our minimum point. Okay, so now the next one, C. Okay, so we have fx equal to negative x cubed plus 8. So this is a cubic function because we have x cubed, but we do have the negative sign. So that means we should start from the left-hand side. And then this one, we will compare them with a, x minus h cubed, and then plus with k. But this time, the h and k is the inflection point. Inflection point meaning that we are going to change the concavity of the graph or the function. Okay, so this one is a negative one, a negative of x cubed. So that means when you sketch, you are supposed to start from the left hand side. So it's supposed to be something from the left hand side. And then somewhere I should change the concave. So mula-mula kita buat macam tu, cantik sikit and then going down. Okay, so those are the inflection points. And then of course we need to know what is our inflection point. So if you compare them, you should be able to see that this one compared with this one, so h must be equal to 0. If you are not sure how, this is x minus h. So this one must be x plus 0. Okay, so h will be 0. And then the value of k is simply at the back over here. So 0, 8. So those are our inflection point. So make sure this point over here is 0, 8. Okay, so this is the inflection point. As usual, we start from the left hand side until we meet 0, 8, and then we need to change the concavity. So start from the left and then you change your concavity. Okay, so now what about the domain as well as the range? Okay, so actually for the cubic function, the domain and range, if there is no restriction, again, if there is no restriction, then the domain and range will be negative infinity up until infinity. So we can actually take any value of x and it will be any value of y. Okay, so that is the range and the domain. Okay, next, let us proceed with the last one, D. Okay, so for D, we have fx equal to the negative 1 over 2x minus 5. Okay, so this is a reciprocal function. For reciprocal, you need to know what are the asymptotes for them. Okay, so for asymptotes, you have two things actually. You have a vertical asymptote and then you have a horizontal asymptote as well. Okay, so vertical asymptote, you simply need to refer to your denominator. So refer to your denominator. Denominator tak cukup tempat. Dino. Boleh lah dino. Denominator. Okay, so look at your denominator. You're going to let them equal to 0. Okay, so denominator equal to 0. So we have 2x minus 5 equal to 0. X will be equal to 5 over 2. So those are our vertical asymptotes. So make sure you draw those dotted line at x equal to 5 over 2. So this one over here, dotted line at x equal to 5 over 2. Okay, so how do we know our horizontal? Okay, so horizontal, normally we're going to look at what number at the back over here. Sebab atas ni dah memang constant kan? Okay, so constant, bawah dia linear. So what is the number at the back over here? So we don't see any number, so this is 0. So that means horizontal asymptote is simply y equal to 0. So this is the horizontal asymptote. We're going to learn more when we go to chapter 8, which is the limit and continuity. So nanti masa masuk chapter 8, kita akan belajar banyak sikit lah pasal asymptote ni. Dia akan banyak lagi pasal sketching. Cumanya sekarang, untuk tahap sekarang, it will be very simple. You just need to refer to your function. What are the numbers that you can see? Is it minus something or plus something? So that number are the horizontal asymptote. Okay, so asymptote, as long as we don't touch that point, that is okay. Okay, so that is the reason why your domain will be negative infinity up until 5 over 2 and then union with 5 over 2 up until infinity. For the range, we are saying that our horizontal or horizontal asymptote is when y equal to 0. So you need to ignore y equal to 0 for your range. So that is the reason why we have negative infinity up until 0, union with 0 up until infinity. Okay, so how do you sketch those graphs? Okay, normally for me, if I have 1 quadrant, 2 quadrant, 3 quadrant, the 4th quadrant, normally for me, I will test some of the value because I know that they will match, right? Okay, so normally for me, if I have 5 over 2, so perhaps I choose something like 10. Okay, so if I choose 10, I will have negative 1 over 2 times 10. Oops. And then minus with 5. So 2, 10, 20, 20 minus 5 is 15. So negative 1 over 15. So now you just need to determine, is it going to be in the first quadrant or is it going to be in the 4th quadrant? So quadrant tu kita refer kepada asymptote lah. Asymptote tu kita ada dua asymptote kan, vertical dengan horizontal. So kita akan bahagikan quadrant tu mengikut asymptote tu. So tengoklah 1, 2, 3, 4. Okay, so 10. So it can either be in the first or the 4th quadrant, but I know for sure if I substitute x with 10, I will get a negative number. So those are below the x-axis. So I know for sure this is the graph. So dia punya pasangan tu yang lawan pada dia lah, yang duduk kat atas tu. Okay, so that is normally how I draw my reciprocal function. Okay, so that's it for sketching graph. So now let us proceed with the composite function. Okay ke graph ni? Ada apa-apa yang nak tanya? A, B, C, D. Is there anything that you want to ask before I proceed with composite function? Is there any graph that is not that clear and you would like me to do it again? Ada apa-apa? Is there any graph that is not clear? Okey je. Okay, orang lain macam mana? Okay. Tiha kata dia okay, orang lain okay. Kenapa ambil dua kali ke dua X kat bawah tu? Dua X kot. Yang ini Sophie tanya yang ini Sophie. Vertical. Vertical asymptote, you need to refer to your denominator. What do you have in your denominator? Wait, okay. Right, so for vertical asymptote, refer to your denominator. So since you have 2x minus 5 in your denominator, you're going to let them be equal to 0. Because basically for anything, you cannot have 0 in your denominator. So those one will become our asymptote because we must never let our denominator be 0. Okay, so if you let your denominator equal to 0, then x will be equal to 5/2. So that means when I draw my graph or when I sketch my graph, I shouldn't have any graph when x equal to 5/2. So my graph won't touch x equal to 5/2. Nampak tak kat sini? Ni yang warna merah ni graph dia tau. Nampak tak? Dia tak sentuh langsung, dia lari. Dia takkan kena dekat 5/2. Same goes over here. This is 5/2 but our graph doesn't touch or doesn't meet, doesn't cross 5/2 at all. So those are what we mean by the asymptote. Asymptote ni senang cerita dia macam boleh tak ni kalau ayat jahat sikit macam virus lah, semua orang lari bila dia. Tengok macam sini kan, dia duduk kat sini kan, graph ni lari. Dia duduk kat sini, okay, graph ni lari kat dia. Larilah. Sama macam the same thing goes over here. This is the horizontal asymptote. That's why you can see that your graph, it will go up but it won't cross this point over here. So dia hanya macam rapat saja, dia tak akan cross kat situ. Kalau awak lukis tiba-tiba je tercross, makanya graf itu adalah salah. You cannot cross your asymptote. So be extra careful when you sketch your horizontal asymptote and vertical asymptote. Make sure your graph doesn't cross, doesn't touch, doesn't meet your horizontal or vertical asymptote. Make sure jangan sentuh langsung lah. Okay, next. Right, so composite function 5.2. Okay, so the learning outcome basically for the second lecture, you should represent the composite function using an arrow diagram and then find the composite function and then find one of the function when the composite and the other function are given. Okay, so basically I think the arrow diagram is quite easy. You can refer to your notes. So I'll just do B and C. Sebab yang ni saya rasa saya perlu fokus sikit lah untuk B and C. Okay, so A, you can read them in your notes. Okay, let's go to B. Okay, so now composite function. If I can do some mind map or the simplified version for composite function, I can actually separate them into 3 different cases. The first one is that they give you what is the F and they give you what is the G. They want you to simply do F composite with G. So this is by the definition. F composite with G, it simply means that we should substitute G into F. So F composite with G, so G into F. Okay, so one thing that you should take note, this is not the degree punya simbol, tapi ini adalah composite. The way we read them is that F composite G. Okay, so this is the normal version. You have F, you have G, and then you simply need to do F composite with G or G composite with F. So those are the first case for composite function. Very straightforward. The second one, they give you the composite function. They give you Fx, Fgx, and then they give you one of the function which is Fx. So they give you what is this value over here, and they want you to find out what is Gx. So in this case, I call them as the inner function. Okay, so they give you the outer function and they want you to find out what is the inner function. And then the third cases is they give you the composite function fgx and they give you what is the inner function, but they want you to find out what is the outer function. So those are three different cases for composite function. So basically we're gonna have either one of these three cases. Bila-bila lah untuk UPS ke, untuk PSPM ke, lebih kurang macam ni lah. So, composite function can be separate into three cases only. Only three. Ada tiga je. Tak ada banyak pun. You just need to make sure you know how to find out each of them. Okay, so this is one note that I think very useful for you. F composite with G is not equal to F multiply with G. So, do make sure to be extra careful. F composite with G is not equal to Fx multiply with Gx. So be careful. This is composite function. This is simply multiplication. So when you write them down, make sure to be careful then. Okay, next. Right, so this is A, case A. So very straightforward, case A. The function f and g are defined by, so we are given fx. Fx is 3x squared plus 1 and gx is 5x minus 7. And they want us to find out what is fgx and then ffx. Okay, so firstly, let us refer to fgx. Okay, so what is fgx? If you go to the definition, fgx, that means we simply gonna substitute g into f. Okay, so this is how I'm saying that I'm gonna substitute g into f. Okay, so f and then bracket gx. Okay, so g into f. Okay, so fx is equal to, so fx is equal to 3x squared plus 1. And then gx is equal to 5x minus 7. So what do I mean is that every time I see this x inside the f, I will replace those x with g. Okay, so gx is 5x minus 7. So every time I see x inside the f, I will replace them with 5x minus 7. So they will become 3, 5x minus 7 square, and then plus with 1. Okay, so they will become 3. So 5x minus 7 square, so this is 25x. 5, 7, 35, 70. So minus 70, oops, square. 70x and then plus with 49 and then plus with 1. So make sure to simplify them. So those will become 75x square minus 210x and then plus 148. Okay, so we simply substitute G into F. So very straightforward, just like what we did in the first lecture. Okay, so now FFX. Okay, so Fx is equal to 3x squared plus 1. FFX, that means I will substitute F inside the F. So every time we see the X over here, we are going to replace them with Fx. Okay, so now I will substitute x with 3x squared plus 1. So every time we see the x, we are going to replace them with 3x squared plus 1. So they will become 3, multiply with 3x squared plus 1 square, and then plus with 1. Okay, so this one will become 3. So 3x squared plus 1 square. So this one will become 9x to the power of 4 plus 3 times 1, 3, 3 times 2, 6. X square plus 1 and then plus another 1. So make sure you expand this bracket very, very carefully. And then expand them. So they will become 27 x to the power of 4 plus with 18x squared and then plus with 4. Okay. So those are F composite with F. Alright, so not finished yet with example 1. We still have the C and the T. Actually dah siap, aku belum salin. Tunggu siap nak. Kau dah tengah salin lagi kan. Sekejap. Tunggu sekejap. Okay, so now see GF1 and GGF. Okay, so GF1, so that means we should calculate first what is GFX. So we're going to calculate what is the composite function for GF in terms of X, and then I will replace the X with 1. Okay, so now GX is equal to 5x minus 7. Fx is 3x squared plus 1. Okay, so what do we mean by GFX? So by definition, they are supposed to be F inside of G. So every time we see the X in G, we should replace the X with Fx. Okay, so they will become G 3x squared plus 1. So replace the X with 3x squared plus 1. So this one will become 5 multiply with 3x squared plus 1 minus with 7. Okay, so now expand them very, very carefully. So you got 5 times 3, 15x squared plus 5 minus with 2. So those will become 15x squared minus 2. So this is GFX. What is GF1? So GF1 simply substitute x with 1. Substitute x with 1. Okay. So now substitute x with 1. We are going to get 15 multiplied with 1 and then minus with 2. So 15 minus 2. The answer for this one is simply 13. Okay, done with C. So now D. Okay, D, G, G, F, X. Okay, so sometimes when you see 3, it might be a little bit intimidating, but just remember when we are doing composite function, we always start from the back. So this one, you should solve GF first before you can substitute or composite with the G. So make sure to find out what is GF. We always need to start at the back. So dia bukan macam number lah. Number kita start pada depan kan. So mungkin ada nak buat GG dulu. No, you have to start from the back. Okay, so we have to do what is G composite with F, and then we're gonna do G composite with that value. However, we already calculate G composite with F over here. So I already have the value, which is 15x squared minus 2. So I will use the value inside here. Okay, so what is my Gx? Gx is 5x minus 7. Okay, so GGF. So this one will become G, 15x squared minus 2. So every time we see the x, we will replace them with 15x squared minus 2. Okay, so replace with 15x squared minus 2. So they will become 5. Multiply with 15x squared minus 2 and then minus with 7. And then do make sure to expand them, write them down very, very carefully. So the final answer for this one is 75x squared minus with 17. So those are example 1, A, B, C, D. Okay, so we got 3 more example to go. Okay. Right, so now let us proceed with the next one. Right, so composite function, we can actually separate them into two. Either we want to find the inner function or we want to find the outer function. Okay, so they will give you the composite function and one of the function, you need to find another one. Composite function, another function, and then find out one of them. Okay, so what happened for each of them, I give you a few steps. Uh, I'll teach you later how to use this step. So sekarang ni kalau nak snap dulu pun boleh lah. Sekejap, erase dulu. Okay, just in case you want to snap first. Nak screenshot dulu ke apa ke before I explain. So I give you 10 seconds for you to screenshot. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go. Okay. Right. Okay. I think it will be easier if we see the example straight away daripada kita tengok formula saja. Baik kita tengok example. How to do the example according to this step. Okay. Right, so this is P. Given that gx is 2x plus 1, gfx is x squared plus 4x plus 5. Find what is fx. Okay, so you need to find fx. So do check where is the f based on the composite function. So the composite function, we have gfx. So f is over here. So f is the inner function. So we want to find the inner function. So make sure you refer to the note, the inner function. So that means this is case B because we want to find the inner function. However, the formula over here is using FGX. So I change the place a little bit. So untuk nota saya kat sini saya tukarlah daripada FGX kepada GFX. Tak kisah pun, okey je. So nanti tengok balik tukar kedudukan saja. G jadi F, F jadi G. Okay, so what do they say over here? Start with the composite function. So where is composite function? Okay, here they are. So we must make sure we start with the composite function. So write down the composite function first. Okay, so g of x is equal to x squared plus 4x plus 5. So that is the first step. You start with the composite function. Done. Done with the first step. Done. Okay, what happened next? Write g of x as g of x. Okay, so make sure you use the definition for them. So this is by using definition. So where do you want to change? Of course, you have to change the left hand side. So the second step only refer to the left hand side. Okay, so based on the left hand side, we are going to write this using the definition where we have g and then inside the bracket fx. Okay, so g fx, we're gonna write them down as g fx. Okay, so what happened next? Okay, so what happened next is that we are going to write function g in terms of fx. Okay, so g fx. Okay, so what is your gx? Okay, so gx is 2x plus 1. So that means if you have g fx, replace the x over here with fx. So dekat mana kita nampak x, kita akan gantikan dengan fx. So this one will become 2fx plus 1. And they will be equal to x squared plus 4x plus 5. So the only thing that changed over here is the left hand side. So instead of writing down gfx, I will use gfx with a bracket over there. And then I will replace the x inside the g with fx. Okay, so now what happened is that we are going to make sure we have fx as the subject. So this is the fourth step. We are going to make fx as the subject. So I will have to deduct 1 and then divide everything by 2. So fx will become half x squared plus 4x and then plus with 5 with 4. 5 minus 1, right? So we are going to get 4. Okay, so of course you can actually simplify them further. You can actually do computing the square for them where they are actually x plus 2 square. So you can write them down as half x plus 2 square. So it doesn't really matter whether this one or this one. That will be totally fine to give them either one. Okay, so again, what happened? We start with the composite function. So writing down g f x equal to x squared plus 4x plus 5. And then make sure the left hand side you change it to so G fx. Kalau rasa macam tak clear lah kat sini, I give you another one. So x square plus 4x plus 5. So this is the second step. The third step, you simply change the formula. Okay. Okay. Alright, you simply substitute the x with fx. So 2fx plus 1. So this is equal to x squared plus 4x plus 5. And then you will get what is your fx. Okay, so those are the 4 steps. So semua yang kita buat tu kebanyakannya melibatkan yang sebelah kiri. So that is why we start with the composite function. Okay? Kot lah tak faham step yang kiri ni. Sebab tu saya buat yang step yang kanan. Right, so done with that. Let us do the next one. Example 3. Okay, so example 3. If gx is 3 plus x and fgx is x squared plus 6x plus 10, find what is fx. Okay, so we have fgx. We want to find what is fx. So based on your composite function, where is the f? So f is over here. So f is the outer function sebab dia bahagian luar. So ini adalah outer function. So make sure based on our note over here, they should be this one. We want to find the outer function. Okay, so I'll copy down the formula first. So those are the steps. We already have the step, so those will guide us what to do. Okay, so now I say start with the composite function. So make sure where is the composite function, write them again. Okay, so we are going to write fgx equal to x squared plus 6x and then plus with 10. Okay, so what happened next? So this is based on the left hand side. So for the left hand side, you have to write down fgx as f composite with g. So this is by using the definition. Okay, so we are going to have f 3 plus x equal to x squared plus 6x and then plus with 10. Okay, so you simply substitute what is the g inside here. Okay, so this is f gx equal to x squared plus 6x and then plus with a 10. So those are the left hand side. So see, we don't do anything with the right hand side. We simply do something with the left hand side. Okay, what happened next? You need to let u equal to gx. So based on your function on the left hand side, so this is f, right? Whatever that you have inside your bracket, those one will become as u. So we're going to use u for the thing inside the bracket. Okay, so let u equal to them and making x as the subject. So we're going to let u equal to 3 plus x. So that means x will be equal to u minus 3. So those are the third step. What happened with the fourth step is that we are going to write everything in terms of u. So that means on the left hand side, since we already replaced 3 plus x with u, they will become fu. On the right hand side, we still have something with x. This is x, this is x. I will replace all those x with u minus 3. So fu will become u minus 3 square plus 6, u minus 3 and then plus with 10. And then of course you should simplify them a little bit. So this is u square minus 6u plus 9 and then plus with 6u minus with 18 and then plus with 10. So negative 6u, positive 6u, those two will cancel out. So you have 9 minus 18 and then plus with 10. So minus 9 plus 10. So the answer will be 1. So we have u square plus 1. Okay. However, that is fu. We want to find out f x. So what happened next is that we simply change the variable back to x. So fx will become x squared plus 1. So instead of u, we will replace everything in terms of x. So fourth step done, fifth step done. Okay, so this is the first step where we are going to write them first. And this is my second step. This is the third step. And then this is the fourth step. And then this one basically the fifth step. Okay, so make sure to follow the step and you will be okay. Dapatlah soalan sini siapa pusing macam mana pun, you are supposed to be quite okay. Oh, by the way, you will have your pre-UPS next week. So next week ada pre-UPS semua orang hari Selasa malam. Selasa malam pukul berapa? Pukul 9 kot. Hari tu start pukul 9 kot. 9 atau 8.30 macam tu lah. I'll update later. If I'm not mistaken, 9 o'clock. Nantilah saya update balik. Okay, done with this one. Let us proceed with the last example for today, which is example 4. Okay, so function f and g are given by fx is x plus 4, gx is x plus 2. Find h such that hgf is x squared plus 8x plus 3. Okay, so we want to find h. Where is h? H is over here. So this is the outermost function. So sebab tu saya tulis case C dekat sini. The outermost function. Okay, so what should we do? We should write the composite function first. So HGF is x squared plus 8x plus 3. Okay, so in order to do the composite function, you should start from the right hand side. Right? So kita start dari kanan. So we have to know what is G composite with F first. Sebelum kita cari H tu apa. Okay, so how to do G composite with F? So that is why I wrote down A. So those are just a simple composite function. You are given Gx. Gx is x squared, and then you will do fx is x plus 4. You were told to calculate what is gf. Okay, so gf, that is f inside the g. Okay, so f inside the g. So every time you see x in g, you will replace them with fx. So that is how you get x plus 4 square. Okay, so now I will go back here and then I will write this down as h, and then the value for g composite with f, and this is equal to x squared plus 8x plus with 3. Okay, so gf is x plus 4 square, so I will write down h x plus 4 square equal to x squared plus 8x and then plus with 3. Okay, so if you refer to the notes that I give you, that means this is already in the third step where we have to use substitution. Okay, so you're going to let everything at the back here to become u. So u will become x plus 4 square, and then you are going to try to make x as the subject because we want to change everything in terms of u. Okay, so u is equal to x plus 2 square. So making x as the subject, we are going to get x equal to square root of u minus with 4. Okay, so once you have x equal to square root u minus with 4, you are going to go back to this function over here and then replace everything in terms of u. So those are the fourth step because we want to find out hu. Okay, so HU, they will become, so this is x squared, right? So x squared, 8x, and then plus with 3. Okay, so set U minus with 4 square plus 8 multiply with set U minus 4 and then plus with 3. So expand them very, very carefully. So this is U minus with 8 square root of U and then plus with 16. And then this one over here, this is 8 square root of u minus with 16. So this is 32 and then plus with 3. So simplify them. Okay, so once you simplify them, they will become u minus 13. Okay, so these two will cancel out. So we only have 16 minus 32 plus 3, and then u minus the answer. Okay, so HU is equal to U minus 13, but this one is in terms of U. So you have to go to the fifth step where we have to change them back to X. So HX is equal to X minus 13. So that's it for the composite function. And I think that's all. Okay. So now, what is the most important thing for your notes? For the composite function, you must make sure you have the notes for for this one. Oops, lajunya. Tertekan. Balik, balik. Okay, make sure ada nota untuk yang ini. Inner function, outer function, and then one more thing yang saya pecah kepada tiga tu, yang ada ABC tu. So, gabungkan dua nota tu lah. And then you akan dapat nota untuk composite function. Yang ini saja. So, those are for composite function 5.2. Okay, so that means next week on Sunday, when I see you, we are going to learn 5.3, where we have the inverse function. So after we learn about the inverse function, we are going to proceed with the exponential and log. Okay, so that's all for today. So I'll see you guys this coming Sunday. Thank you very much for listening. Thanks for watching. So I'll see you guys this coming Sunday. Have a nice day, everyone. Bye bye.